Hello everyone, this is Mr. Molo with a lesson on geometric sequences. So we just got done doing arithmetic sequences, and if you remember those are adding and subtracting patterns only, and so geometric sequences is only multiplying patterns, and that's kind of an important note. There's no pattern for dividing, so it might look like we're dividing here, but that means we're really multiplying by a fraction. And this is actually 2 lessons here in this video, so you're going to have to pause it and then come back the next day and watch the rest of it. So part 1, we're just going to be recognizing and extending the geometric sequence, kind of like we did with arithmetic sequence. And then part 2, we're going to be finding the nth term. So remember, that's when they say find the 50th term or the 80th term or whatever it is. So let's start with the kind of simpler part where we're just going to be finding what it is. So first of all, a geometric sequence is a sequence where the terms differ by the same non-zero ratio r. So one difference between geometric sequences and arithmetic sequences is instead of finding the difference, we're finding the ratio. So we're not finding d anymore, we're finding r. But it's pretty much the same thing. What's the difference? What is being multiplied by each time? And so that common ratio is the constant ratio of any term of the previous term. All right, so if we look at some examples, we need to find the next 3 terms in each of these geometric sequences. So we have 2, 4, 8, 16. This is also a case where a calculator is going to help a lot, because even, ones that start off with 2 here, by the time we start multiplying, they get kind of big. So 2, 4, 8, 16. So the pattern is we're multiplying by 2. So that's our pattern. So times 2. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So then our next 3 terms would be 16 times 2, which is 32. 32 times 2, which is 64. And 64 times 2, which is 128. So those would be the next 3 terms. If I look at example B here, I have 1, 4, 16, 64. So same thing. Looks like we're multiplying by 4 this time. So 1 times 4 is 4, 4 times 4 is 16, 16 times 4 is 64, 64 times 4, already getting kind of big here, is 256, good thing I have a calculator, times 4 again is 1024, and then times 4 again is 4096. Okay, last one on this page, 3, 6, 12, 24. Okay, so this one again, we are multiplying by 2's just like A, except now we're starting at 3, but it's still the same result. We're going to multiply by 2. So 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24, 24 times 2 is 48, and then 48 times 2 is 96, and 96 times 2 is 192. All right, and then the next one, same thing, finding the next 3 terms, and this is where I talk about where it kind of looks like it's going to be a dividing pattern because we're getting smaller. So 320, 160, 80, and 40. So it looks like we're dividing by 2, but remember, the same thing as dividing by 2 is multiplying by 1/2. So on a quiz or a test, don't put dividing by 2. That's not going to be right. It's really multiplying by 1/2, and that goes true for the same thing. If it says divide by 2, that's the same as multiplying by 1/2. If it says divide by 3, that's the same as multiplying by 1/3. If it says divide by 4, that's the same as multiplying by 1/4. So that pattern kind of holds true. So if you can see that it's a dividing pattern, really just put a 1 over it. So instead of divided by 3, put times 1/3. Instead of divided by 4, put times 1/4. So if I keep multiplying these by 1/2, 320 times 1/2 is 160. 160 times 1/2 is 80. 80 times 1/2 is 40. Half of 40 is 20. Half of 20 is 10. And half of 10 is 5. Okay, here it kind of gets tricky because now it looks like we're multiplying by something that makes the next number negative. So 4 times something gives us negative 12. Negative 12 times something gives us positive 36. Positive 36 times something gives us negative 108. So we know we're multiplying by something negative. And 4 times 3 gives us 12. So we have 4 times negative 3 to give us negative 12. And then negative 12 times a negative 3, now we have 2 negatives, is a positive 36. And then positive 36 times a negative 3 is a negative 108. Now again, I have 2 negatives, negative 3 and negative 108 is a positive 324. Now a positive times a negative gives us another negative, and it's negative 972. And then I have another negative times another negative, and we get 2,900 116. All right, last example would be -9 to 3 to -1 to 1/3. So it's another one where it looks like we're getting smaller. So we'd be dividing, but we're really multiplying by a fraction. So it looks like we're dividing by 3. And like I said up here, the same as dividing by 3 is multiplying by 1/3. And since we're switching off negative, positive, I know I'm multiplying by a negative number. So -9 times -1/3 is a +3. +3 times -1 is, I'm sorry, +3 times -1/3 is -1. And then -1 times -1/3 is +1/3. And then I can keep this going. I'm going to have a -1/27. I'm sorry, 1/9. And then a +1/27. And then a -1/81 if I keep multiplying by a third. All right, so that is all there is to the first day of the assignment. So if you're only doing day 1, you can stop the video here, and then we'll get into day 2, where we're actually finding the nth term. There's your homework for day 1, and then here we are in day 2. We're going to be finding the nth term. So similar to last one, there's a formula here, and again, a lot of the things stand for the same thing. So A1 is still that first term. R is kind of that new D difference. We're going to find the rate, and then N is still that number we're looking for. So if it says find the 50th term, we're going to put a 50 there. It says find the 80th term, we're going to put an 80 there. So it's kind of the same thing. The only thing that's a little tricky about this one, if we notice this is an exponent. So we're going to put that to whatever power. And that usually means we have to do that first in the calculator because of order of operations. So we should figure out whatever that is first, because exponents, and please excuse my dear Aunt Sally or PEMDAS or whichever way you learned it, comes before multiplying. So we need to make sure we do that part first. Okay, so this one, what is a sixth term in a geometric sequence when A1 is 5 and R is 2? So again, this is one of those things where we can use the formula to figure it out, or we can kind of just figure out what it is. So it tells us the first term is 5, and we're only looking for the sixth term. So I said in class when we did arithmetic, sometimes it asks us for like the 7th term or something like that. Well, it's not so hard to do it that way. If it asks us for like the 600th term, we're going to want a formula because we're not going to want to multiply it out 600 times. But now that we're only asking for the 6th term, I'll do this one twice to kind of make sure we get the right answer. Okay, so for A1 is 5, and our ratio, is timesing by 2. So 5 times 2 is 10. And then we have 10 times 2 is 20. 20 times 2 is 40. 40 times 2 is 80. And 80 times 2 is 160. Okay, so we can do it that way. Our sixth term is 160. Or if we go back and look at this formula, so we have A1 times R, and then to the n minus 1 power. So here, A1 is still 5, times our rate, which is 2, and we're an n to the first power. So that would be 6 minus 1. Okay, so if I simplify that, so 2 to really the 5th power. So if I have a calculator and I can do 2 times 2 times 2 times 2 times 2 to the 5th power, that means that's really 5 times 32. And 5 times 32, guess what, is 160. So no matter what, I get 160 there. So like I said, you can either write it out when it's asking for something small like the 6th term, or I can kind of use that formula that we just learned if we're looking for something maybe a little bit bigger. Okay, here kind of the same thing. So they give us the first term, they give us the second term, they give us the third term, they give us the fourth term. So I need to find the 5th, the 6th, the 7th, the 8th, and the 9th. So again, not that much work to find 5, 6, 7, 8, 9. So I might just do this one both ways as well. So it looks like our pattern, 2 to 6, 6 to 18, 18 to 54, looks like we're multiplying by 3. So if I multiply by 3, the 5th number is 162. 6th number is 486. Keep multiplying by 3, I get 1458. Again, calculator is really important here. I'm not doing this in my head. I just have a calculator in my hand. Oops, that's a 4, not a 2. And 13,120 2. Okay, so I can get 13,122 if I do it that way, or if I use my A1 times R n minus 1. So my A1, my first term is 2, times R, my rate, it's being multiplied by 3, and n minus 1, I'm looking for the 9th term, so 9 minus 1. I get 2 times 3 to the 8th power. Let me figure out what 3 to the 8th power is. It is 6,561. So I have 2 times 6,561. And since I already know the answer is 13,122, I'm going to take a wild guess and say 2 times 6,561 is 13,122. And I just put in my calculator to make sure, and I was right. So no matter what, we get 13,122 as our answer there. Okay, let's look at one more here. So the first term of a geometric sequence, it is 1, and the common ratio is 10. What's the 10th term? So again, this is probably one I'm going to want to do, not going to want to write out it 10 times. So I'm going to use my formula here on this one. So A1 times R n minus 1. So it tells me the first term in the sequence is 1. And it says my ratio is 10. And I'm looking for the 10th term, so 10 minus 1. So then I do 1 times 10. 10 minus 1 is 9. So really whatever 10 to the 9th power is. So 10 raised to the 9th power. Whoa, how many zeros we got there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I got 1 times 1, 2, 3, 4. Actually, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what is that? That's 1,000. That's 1,000,000. So a billion there. And then 1 times a billion is just a billion. Okay. So we could do it that way. Or we could have written it out as 1 by 1. Okay. Let's look at this last one. So here we have our sequence is 3, 6, 12, 24, 11th term. Again, I'm not going to want to write this out another 7 times. So I'm going to go with my formula here. If you want to write it out 7 times, again, go ahead by any means. If you want to do it that way, it's up to you. So my A1 here is 3. My rate, it looks like we're multiplying by 2. And then the 11th term, so 11 minus 1. So 3 times 2 to the 10th power. So I got to figure out what 2 to the 10th power is. That is 1,024. So 3 times 1,024 gives us 3,072. All right, so that is your lesson on geometric sequences, part 1 and 2. First part where we found the next terms and just found what the ratio was. And then part 2 where we actually figured out the 10th term or 11th term or 7th term. So that should be it for this lesson.